So the easiest way I found to do this is to do it side by side. So I'm going to do a distance. And the distance formula is easy. Distance equals rate times time. But I'm going to work this thing side by side. Rate times time. So in the first one I'm going to use, on the left side, I'm going to use numbers. And on the right side, I'm going to do the exact same thing except without numbers. So if I tell you that the distance is 670 meters and the time is 134 seconds, then I know that I can plug those numbers in for D and substitute them in for T. So I have 670 equals R times 134. Well, I don't have anything to plug in here, so I'm just going to bring that straight down. Now to isolate the variable on the right, that means that I need 1 R, so to get 1 R, I have to divide by what I'm multiplying by, which would be the 134. Well, I have this thing called the multiplicative property of equality that says that if I multiply or divide by something on one side, to keep it an equality, I have to do it on both sides. Well, since 134 was T, I actually divided by T over here. So if I divide by T there, and I divided by T on the other side, because 134 was my T. Now then, I've got 134 divided by 134, which is 1, and T divided by T, which is 1. Then I end up with 670 divided by 134. That's 5. And I have meters per second because this was meters and this was seconds. And that equals my rate. Well, D divided by T, that's all I can do. I can't divide those out. So D over T equals my rate. Now, what if I did something like the area of a triangle equals the base times the height divided by 2, or 1/2 the base times the height? So if I give you numbers on the left, so if I tell you that the area is 36 meters squared and the base is 9 meters, then I can plug that in. So I end up with 36 equals 9h over 2. Well, I don't have anything to plug in this one, so I'm just going to bring it straight down and keep it just like it is. Now the next thing I'm going to do is get rid of this pesky denominator over here. And then, so I'm dividing by 2. To make that be a 1, I'm going to multiply by 2. So if I multiply this side by 2, then that multiplicative property of equality says that I have to multiply that side by 2 also. Well, let's do the same thing over here. So I'm going to multiply that by 2, and then I'm going to multiply the area by 2. Now, 2 divided by 2 is just 1, and 36 by 2 is 72. So that 72 equals 9h. Well, now let's go do that same math on this side. So 2 divided by 2 is 1. And I'm left with 2 times the area equals the base times the height. Now to finish this thing out and isolate this h and make it 1h and not 9h, that means that I have to divide that by 9 because I need that to be 1. And that multiplicative property of equality says that if I do it to one side, I have to do it to the other to keep it equal. Well, then 9 divided by 9 is 1, and 72 divided by 9 would be 8. So 8 equals H. But let's do that same step over here. Well, we really divided by our base because we said the base equals 9. So I divide by base there. Then I have to do it on the same on the other side because that equality thing. And then if I divide b by b, that gives me 1. So I end up with 2 times the area divided by the base equals the height. Let's get just a little bit more complicated. Of course, why not? And use our old friend, the pendulums. So I can tell you the time it takes for a pendulum to swing by knowing the length of the pendulum. So if I know that the time it takes for a pendulum to swing is 2 times pi times the square root of the length of the pendulum divided by the gravitational constant. I'm going to write that down over here too, because we're going to work them side by side. 2 pi times the square root of the length of the pendulum divided by the gravitational constant. So if I tell you that it takes 2 seconds for my pendulum to swing, I need to know how long my pendulum needs to be. So where it says t, I'm going to plug in 2. And then everything else I know, let's use the gravitational constant to be 9.8 meters per second squared. That's a constant. We know that. So I can plug that in. So the length of my pendulum divided by 9.8. Well, I don't have anything to plug in on this side except the gravitational constant, so let's just leave it as g over here. So I'm going to say t still equals 2 pi times the square root of the length of the pendulum divided by the gravitational constant. Cool. Now let's solve this thing. So the first thing I'm going to do on this side is I need to isolate this square root. To do that, because I'm multiplying by 2 pi, I'm going to divide by 2 pi. So if I divide that whole thing by 2 pi, again, I have to do it over here because that equality thing says I do. Well, 2 pi divided by 2 pi equals 2 over 2 pi equals the square root of the length of the string divided by 9.8. I can divide out that and make that be a 1, so it's 1 over pi. Now what if I do that over here? Then I have, if I divide by 2 pi here and divide by 2 pi there, then that's my 1. And I end up with my time divided by 2 pi equals the square root of the length of the pendulum divided by the gravitational constant. Now I have to get rid of the square root sign. Well, the opposite of square roots is squaring. So if I square that side and I square that side, then I end up with 1 squared over pi squared equals the square root goes away, equals L over 9.8. Do the same thing without any numbers. I'm going to square both sides. So that would be t squared over 2 squared would be 4 times pi squared. And that equals the length of the string divided by the gravitational constant. Wow, I'm getting somewhere now. So, the only thing I lack now, isolating the length of the pendulum, is to get rid of this g in the denominator, which means over here I'm going to multiply this times 9.8. But if I do that there, I have to do it there also. So I have 9.8 times 1. That would just be 9 8/10 over pi squared equals the length of the string, or the pendulum. Do the same thing on this side, but instead of 9.8, which is our gravitational constant, we're just going to multiply it by g. Well, if I do it to one side, the equality property says that I have to do it to the other side. Well, g divided by g is 1. So I have the gravitational constant times t squared all over 4 pi squared equals the length of the string. Now I can figure this out, and I have done the math, and this ends up being like 0.9929 meters equals the length of the string. So that's what I've got. I do them side by side, so that as I do one step with numbers, I do the same step without the numbers. Let me know how it goes, and hope it works for you.